Hi, everyone. First of all, I'd like to thank everyone for joining us today here in our session. We'll discuss about things that people are doing that eventually lead to high CVs. We'll discuss about different strategies that you can implement to achieve low to zero CVs. And we'll discuss some tools that you can use in your workflows to achieve that zero CV mark. Uh, a little bit about me. I'm currently a maintainer for the Captain project, which is a CNCF incubating project, and I also contribute to BuildSafe, which is a supply chain product that we have built, open source project. Harsh, would you like to introduce yourself?
So I work as infra engineer at Civo, and I also started this project BuildSafe, which we'll talk about. And we previously spoke about it in the morning, but you'll see more of it now. So security teams are tired, but second. Yeah. Cool. Yeah. So yeah, security teams are definitely tired. Um, so they have to wake up due to CVE alerts even in 2024. They do not know if a dependency is crucial or not. Okay, this is a critical dependency. Okay, I'll stay away from the wires. Yeah. So they do not know if a dependency is crucial or not to the application. Uh, yeah. So security teams still do not know if a dependency is crucial or not to their application. They do not have a consistent way of managing updates for the OS dependencies because we as developers sometimes use multiple package managers based on our taste. We sometimes use random curl commands to download dependencies from the internet. So all of this comes back to bite the security teams. Um, so ever since we had virtual machines and ever since we had this vulnerability database as a concept, we have been scanning for CVEs. We have been finding hundreds of them. And we focused primarily on prioritizing CVEs. We have come up with various metrics on how to measure, but we have focused very little on automated patching as a genre in OS dependency updates, even with virtual machines and even with containers. And by OS dependencies, I mean dependencies like glibc or get something you would do with apt install, apk add, things like that, right? So how do we currently manage just to evaluate where we are for our workloads? We use OCI images, right? So for base images, we could just create a base image, use a base image, generic base image like Ubuntu, and we could wait for the tag to be updated. But the drawback is sometimes it can take months, and sometimes not all dependencies, all updates are given for all the packages. So relying on third party and like more the middlemen in this process of dependency updates, less control we have over our software, and sometimes that's not an acceptable risk. So since we do not have granular control of dependency updates, we should try to fix that. And it's also possible that since we use this generic base images, we could end up on a really slow moving distribution where the package distribution itself isn't coping up with the software patches which upstream source code repositories maintainers are making. Then there's also the complexity of multiple package managers. Like imagine a security team has to deal with n number of package managers. They'll have to figure out n number of ways to make a patch in those ecosystems. And typically, whenever a CV where they have to take action, this is what happens. Vulnerability is announced. They have to check if a patch is available. They have to check which software is impacted from that, and that's a process which we have evolved a little in, but it's still a problem. And then they have to go and manually patch. This could take like 1 to 2 weeks on a good and simple vulnerability, but it could also take months. So not an ideal situation for teams to be in. So how do we solve this?
Yeah, so coming to the solutions or strategies that we can implement to overcome this flood of CVs, the first one can be the use of minimal dependencies. So what companies or people usually do is they'll have this generic image in the Docker file, which can be like Ubuntu, and it'll have like 100 dependencies related to it. And in like in actual there are only 20 dependencies that are being used by by the project. So every dependency, like the rest 80 dependencies, are increasing the risk of the CVs that are there for your project. So you should try to use minimal dependencies, and how you can do that is by using creating your own base images. There are usually two approaches on how you can create base images. The first one is top-down approach, in which you have an image, like let's say Ubuntu, and you tear it down. You remove the unwanted dependencies to achieve that low CVE mark. And the second one would be the bottoms-up approach, in which you have an image from scratch, you add the required dependencies to it, and you then reach the low CV base image mark.
Yeah, and just to add a point that there's a popular example of Talos and AWS bottle rocket. AWS tried to do the tops down approach, and they ended up with 350 binaries. So that's 350 binaries packages they have to maintain updates for. Whereas Talos built it from scratch, and they only have 12 binaries that they have to deal with. So it just shows that less dependencies come a long way in managing security updates.
The next one would be declarative management. So what this means is, let's say you take an example of Golang. You declare every dependency that is there, which will be required for a project. If you do the similar way for OS dependencies, that would be declarative management for OS dependencies. It helps to eliminate the implicit behavior problems, which means that sometimes there might be some hidden relationships between your dependencies, and that might create some implicit behavior problems. Declarative management helps to solve that. And then declarative management also helps to automate the patching part for vulnerabilities. So yeah. Over here, we have a stat from Repology, which is a project that tracks all the packaging information for different package managers. It shows all the package managers that are there, all the total packages that are there for a package manager, and how much the potential vulnerability for these package managers are. Over here, if you'll see Nix packages, which is a declarative package manager. Yeah, Nix packages, which is a declarative package manager, has the most amount of packages as compared to Ubuntu and Alpine. And if you'll see, the potential vulnerability for it is zero point 0.2, which is less than the Ubuntu and Alpine, which proves the point that having declarative management is the part of patching vulnerabilities. Then using a single package manager, let's let's say you have a security team in your company, and a CV comes, and you are using multiple package managers. So what security teams usually do is they'll have a fix for us for the CV, and they'll push fixes to different package repositories using different recipes, which eventually takes a lot of time. So having a single package manager helps to solve that. Then, yeah, it simplifies the dependency management, makes it easy to track and update dependencies, and eventually, what you should aim is have a internal package registry. What it means is you have all the packages inside a internal package registry. You can perform customized checks on these packages, like let's say you track down all the DNS queries that are there for a package, and in future, if there are new DNS queries for a package, you track it down, like what's happening and stuff like that. But this should be something that you should aim down the line as things grow, your company grow. Yeah. Then automated patching. The things that we just discussed, like the single package manager, minimal dependencies, these are already being followed if you pay attention. For let's say we take an example for Golang. We have a single package manager for Golang. The dependencies that are defined in the go.mod are the ones that are actually being used. So the minimal dependencies concept is already being used, and those are declarative defined in the go.mod. But for OS dependencies, that's not the case. We usually do this run command that which downloads unwanted dependencies, and we have renovate and dependabot, which helps us to automate patching uh, for language dependencies, but we don't for OS dependencies as of now.
So that's where BuildSafe comes in. So our aim is to automate OS patching, OS package patching, help you create zero CVE base images. It's built on declarative package managers such as Nix, and we try to provide high quality metadata uh, such as SBOMs and provenance. So the ideal workflow we would want is for the software inventory to be preloaded. Like we should already know about what software we are using rather than at a crisis time where it's hard to find things. So once the software inventory is preloaded to our automation, let's say a GitHub board, it becomes easy to detect whenever there's a new patch available. And then BuildSafe can help you automatically patch this. And this brings down that previous lifecycle we saw about 1 to 2 weeks to just 1 to 2 hours, right? Like we just have to wait for a patch update coming up. So this is what this is what an ideal workflow will look like, where we have the user registering their repo to build safe, and then we run a BSF update, which will on the bottom have this file, this declarative file where we have the dependencies, and once these updates are done on these packages, we generate a base image, and this base image can then be used in a pipeline, and this will keep updating. So I'll just show a practical example. So let's say you have this sample Golang repo, which um, has just a single main.go file. It has a standard Docker file, and you want to try to adopt this project. You can do a BSF init and just answer these prompts. So we want to build a base image. We want to name it something, and we want all the linters. We want it for Go. I'm not going to press enter here because it's going to take 2 minutes of critical time and delay your lunch. So I'm going to check out to a branch where I have it initialized. So basically what it gives you in the end is this file where you have the compiler, Go compiler here, and you have the Go tools, and where you'll have the linter and you'll have the debugger, Go debugger here. And bash and core utils are something which can help you during development. So that is why we have that. And in runtime, we have the CSert image, CSert package, which is critical when you're running your application that uses HTTPS, right? So, excuse me. So then we have these OCI blocks, which I explained in the morning, but basically you just name the image, you specify the layers because you can customize your layers as per your needs. But the interesting thing now becomes, how do we manage updates, right? How do we search for new dependencies? How do we manage updates? So let's say right now there is nothing, like this is just pinned down to 1.22.3, right? So let's say I want to make it like I want to automate that. So I search for BSF, I do a BSF search, Go, and I find all the packages that have Go in them, or I search for BSF go.dev. So it shows me all the packages that whose website is pointed to go.dev. So in this case, we can look at all the versions, we can look at all the licenses. So let's say I go with an intentionally low version for now. I'm going back 1.22.1, and now it's asking me whether I want it in my development runtime, and there's no good reason to have it in the runtime, so we can have it in the development. Lastly, it asks you what update strategy you want. So you can choose if you want a minor update, minor version updates, or if you want patch version updates. Let's go with minor version updates. And now you can see that this BSF HCL file will now have this caret symbol attached. Now what this helps us do is we can automate that by running BSF update, and when we run this, we'll see that it becomes 1.23.3, which is the latest version. So we just went from 1.22.1 to 1.23.3, and this isn't just like a file update program. This actually, when you run a BSF develop, it can help you maintain multiple packages in reality. So you will actually see a Go compiler with that version present. So that was the quick demo. And we try to follow all the principles mentioned here. Like we we pin. So this is given by OpenSSF itself. These principles, and they ask us to pin the packages to a version or a hash, and we do that. We also are supposed to show vulnerabilities and dependencies when installing packages. And trust me, we had that till this week, but we had a bug since then it's been down, but we'll fix that. So you'll have that as well. And we also produce SBOMs when you do a build. So I showed that in the morning, but for demo's sake, I'll have to skip that since we are running out of time. But that's been our focus. Like we have focused on these principles, and we have cracked this.
What else? After this, if you are following these principles, what else can you do to uh, prioritize the vulnerabilities or minimize the vulnerabilities that are there for software? The first thing is the VIX documents. It helps you to prioritize vulnerabilities and helps you with identifying the false positives that are there for vulnerabilities. Like sometimes there might be a vulnerability that doesn't really affect your whole life cycle. So you can prioritize the vulnerabilities using VIX documents. You can ask for VIX documents, which will show you the effect of a CV that will happen to your project.
Yeah, you can also eliminate bogus CVs, eliminate false positives you see. You can also, it's really lunchtime. Isn't it? Yeah. You can also use tools like Kubescape, where you can analyze the syscalls your OS packages have made and help generate and eliminate other false positives your scanners might generate.
These are just a couple of tools that you can make use of if you want to do more stuff with vulnerabilities. There's CV prioritizer, which acts as the VX documents only. Then there's the VX CTL, and then there's BSF.
Yeah. And lastly, we are planning to create this GitHub bot that we showed, that BSF update command, that can vastly help this process and make it completely automated to automate the OS patching. So we won't just have this patching ability for our language dependencies, but for OS dependencies as well. So that we only have to worry about what we need to and just automate the rest. That's our goal. Thank you. And you can join our Discord, and we'll be around. If you see us, just ask for a demo, or if you have any questions, just come out and you can hang out with us. We'll be around. And please join the Discord.